Hello everyone. Welcome to the fifth edition of Lead Masterclass. This is your host for the day, Himanshu. At Lead, we ensure that our students should not only be equipped with excellent academic education, but also with skills that help them to succeed in life. Maths can be fun if students can relate it to real life and are taught in a fun way. Now, to remove the fear of math in students, we are presenting a Lead Masterclass on mental maths. Now, before we begin, a special request, please do ensure that you tell about yourself, where you come from, about your school name, etc. in the comment box. You can see the comment box just below the video. Please do tell us about yourself and do tell us how excited you are about today's session. Now, our instructor for the day, Mr. Debapriyay Mukhopadhyay, has founded the blog Ganit Charcha. He and his team work in popularizing mathematics amongst young schools going students. He has been a corporate professional for the last 20 years and is currently associated with Vihere as a senior product manager. He is working in developing solutions for cyber defense. Sounds interesting, right? Now, kids, without any further delay, let's hear it from Mr. Debapriyay.
Hello everyone, good afternoon. I first would like to thank Himanshu for this nice introduction of mine. I also thank Lead for providing me with this opportunity to interact. Now, before I start, uh, just a few words on mathematics. So, you have seen enough of mathematics because all of you are from grade 7 to grade 9. So many of the mathematics tools, many of the mathematics methods you already have worked through in your previous classes. Uh, but just to let you feel good about mathematics, because mostly people doesn't feel about mathematics. They fear mathematics. They tend to ask questions like, where are mathematics being used? Uh, what is the application of uh, mathematics in real life? Basically, particularly when it comes to higher mathematics and all. Now, there are plenty of applications where mathematics can be used. I can go on saying a few applications which basically the solution of which are basically being borrowed from higher mathematics. Uh, but the basic mathematics that we usually go through in our school curriculum, particularly up to 10th standard or 10 plus 12th standard, basically they are readily applicable in different areas of life. You know that very well. What are those areas? Basically, if you have to design something, if you have to draw something, if you have to measure something, everywhere mathematics comes into picture. That's why if you have to weight something, if you have to quantify something, so there are plenty of real life applications. So I'm not going to get into that because those things will sound boring to you. Uh, but I would like to tell you a few, one example at least. Basically, all of you are nowadays working or basically studying from home, basically doing online classes, uh, communicating with your teacher over different modes of communication, be it email, be it WhatsApp, be it through Google Classroom, be it from using Slack, be it using uh, Teams and all. Have you ever asked yourself this question, that these communication, how these communications are being secured? So these communication is basically end-to-end communication between two devices. One is basically the device that you are using. Say, for example, I am communicating from my own laptop, and you are hearing from your own device, be it a mobile phone or be it a tab or be it a laptop or desktop, whatever it is. So how this communication is being done securely, so that no one can eavesdrop, or so that no one can get into what I am saying or what you are writing or what we are actually talking about. So it's a simple session. So even if someone eavesdrop, or even if someone tries to know whatever we are talking about, or whatever being communicated, it's not a big harm. But it's harmful when you are trying to do some online transaction, particularly while trying to buy something from Amazon. So the solution that is being used till today is basically is called RSA. Basically, it's named after three famous mathematicians or computer scientists. So basically, Rivest, uh, Ronald Rivest, Adi Samir, and Leonardo Adleman. So basically, RSA, that is how it is called RSA. So this algorithm is being used in every computer. This algorithm is being used in every by every device, whoever is trying to communicate over internet uh, securely. But where from this RSA algorithm has got its motivation? It has got its motivation from mathematics, and very basic mathematics. Probably you will understand some of the things too. I will tell you. You know that if I divide any integer by any other integer, say for example, if I uh, divide by 10, the number of remainders that I can have is basically from 0 to uh, 9. If I divide it by 13, the number of devices I will have from 0 to 12. So there is an algebra, or there is a mathematics around it, using these remainder finding mechanism, which is called modulo. Basically, it's a modulo algorithm or modulo method. Basically, modulo means I divide an integer by another integer, and what is the remainder is what is called modulo. So if 5 is being divided by 10, so 5 is the value that I get. So if 5 is being or 18 is being divided by 13, 5 I am getting. So 5 is my modulo. So using this modulo arithmetic and the beauty around it, or some properties of number theory, these whole RSA algorithm is being built. And that algorithm has been built in 1979. And from there onwards, still it is in use. And few developments have gone into breaking this algorithm, but there is still not much success. So still we are using RSA as of now. So this whole thing is being taking its motivation from pure mathematics, or the um, higher mathematics. So there are plenty such examples. It's not about just what we do or what we just measure in day-to-day life. That's one part of it. Now, giving this context, I would like to say that mathematics as a subject is usually being stamped as a boring subject, because you need to remember many formulas, you need to remember many tricks and all. But people are being asked, or students are being asked to remember those formulas or those things only because so that they can do well in their exam, only because there is a time constraint in every examination, so that you can uh, do quickly those things pretty fast, so that you can do things and score more, and can feel confident. So these are basically the reasons. But if you understand the subject, remembering is not needed. uh, what is needed is basically to understand the basics, understand why the subject has got developed, and how this subject has got developed. So starting from the very beginning to whatever you have read, so you need to figure out, or you need to ask yourself questions, and then you need to ask your parents or teachers the questions that why this thing has come, or why I am learning this, and what is the benefit of learning this, how I could think this particular topic in light of earlier topics that I have learned. So there is a connection between all these things. So just to give you one example, so we started our journey by being able to count. So we have started to count, and then we have learned integers, right? So we have learned integers. We have learned basic operations on integers. So we have learned addition. We have learned division, multiplication, subtraction, and all. But then one fine day, you are seeing that you are being introduced with negative integers. Why? Have you ever thought about that? That why negative integers are being introduced? Basically, when you are counting, or while you are doing subtraction, addition, multiplication, division, the date came into picture. There is once people felt the need of representing date. That means you have 5 chocolates, and you have to give 8 chocolates to your class. So that means 3 are due. So you cannot give 3. So on a later day, you have to give 3 more. This may not be an ideal example of debt, but you can craft your own example. But you see that there is a need that the numbers with which we have started to count, those are not sufficient to represent it anymore. So the negative integers came into picture, and your number line got extended from 0 to, in one side, infinity, to other side 0 to minus infinity. That's how negative integers came into picture, and you started to play around with it. You started to generalize the operations that you have learned earlier. Say, for example, you have learned to add. So now you have learned to add a positive integer with a negative integer. You have learned to add two negative integers. So that's basically the generalization of the addition operations. So basically the two debts. So you have taken a loan amount of rupees X, and on the other day you taken a loan amount of rupees Y. So now your debt basically, which is minus X and minus Y. So you need to add, that is minus X plus Y. So that's how things started to roll out. So this is the logic, or this is the thing that you need to think about. Then only you will feel the beauty of the subject. Then only you will feel that the subject is not boring. Then only you will feel the need to apply the right tools at the right problems. And automatically you will feel more confident. Automatically you will feel that how a problem could be attacked, or how a problem could be solved. Because at your age, it is very important right now to understand how to tackle a problem or how to attack a problem. There are n number of ways to solve a problem. There could be. You may not know n number of ways. You have to find out one. And if you are satisfied enough to figure it by figuring out only one method, you may have missed n minus one other methods which could have been used in some other examples, in some other problems. So it's important. So keep it in mind, and that will help you going forward. Now to enter into the main theme, I will start with a magic. So it's mathemagic I call. And basically the recreational aspects of mathematics are beautiful. More you will see, more you will learn, more you will see, more you will understand that how beautiful it could be. Now a simple mathematic I will explain now. So you have to choose a number between 1 and 9 secretly. So everyone try that. At the end, you can share your experience with me. So you secretly choose a number between 1 and 9, 1 and 9. Now whatever you have chosen, you double the number. So you multiply it by 2. And then what next? The number that you have got after doubling the original number, what you have to do next? Himanshu, can you just go forward? Yes, you add 4 with the number obtained in step 2. So you are adding with the number obtained in step 2. Uh, just you add 4 with it. And then you multiply the resulting number with 5. In the next step, you will choose another number between 1 and 9 secretly. These number you have to choose secretly. So at step 1 and step 5, you are choosing 2 numbers secretly. And add these with the number obtained in step 4. So at step 5, you have chosen another number between 1 and 9 secretly. And you are adding that with the number obtained after multiplying it with 5. Now, if you tell me these number, I can tell you whatever you have chosen at step 1 and step 5. How? I will just do a simple step. I will just execute a simple step. What that simple step is? The number that you will tell me at end of step 7, I will simply subtract 20 from it. I will simply subtract 20 from it. And the number that I have is a 2-digit number. And in that 2-digit number, the 1/10th digit is the digit that you have secretly chosen at step 1. And the 1st digit is the digit that you have secretly chosen at step 5. Now, whoever has done these steps, just subtract 20 and see whether I'm saying the right thing or not. Just verify it.
Right, students. So you need to verify. A lot of students are giving the numbers that have come. So let's say 44 is a number which is given by Pratish. Malshri is saying 25. Shakti is saying 34. So students, you have to subtract 20 and see if the number
So
digits
if
at 10.
34 is the result after step 7, so you subtract 20 from it, you will get 14. So 1 you have chosen at step 1 and 4 you have chosen at step 5. You can verify it of your own. So just go on doing these steps once again. If you are not done, you have not done it, and then the number that you have obtained at step 7, you just subtract 20 from it. The resulting number that you have is basically comprised of the 2 digits that you have secretly chosen. Just verify this.
Yeah, a lot of students are saying. So Vijay Kumar is saying yes, it is correct. Anag Anaga Devdar is saying yes, sir, you're right. This is amazing. This is like magic. Yeah.
Yeah, so the same thing I have written over here, what I have just told, that subtract 20 from the shared number to correctly guess the 2 numbers secretly chosen. So this is the trick. Now, if I go back to the earlier slide, yes, have question yourself that why this works. Just question yourself why these works. Now let me tell you the proof that why this works. So suppose I choose a number, any number between 1 and 9, which I represent it as X. Now, all of you know how to use X, how to use algebraic unknowns. So all of you have learned that. So just think that first step I have chosen x, a number between 1 and 9. So I am doubling the number. So doubling the number means it's becoming now 2x. Then I'm adding 4. So my new number after step 3 is 2x plus 4. Then I'm multiplying the number. So 2x plus 4 is being multiplied by 5 becomes what? 2x into 5, that is 10x. And plus 4 into 5 is 20. So it becomes 10x plus 20. Right? I hope all of you are with me. So it's now 10x plus 20 at the end of step 2. Now we have chosen another number between 1 and 9. I represent it as y. And you are adding this y with 10x plus 20. So what is your new number? Your new number is 10x plus 20 plus y. And this is what you are communicating to the magician. So magician now knows the number 10x plus y plus 20. He subtracts 20 from it. So what he has? He has 10x plus y. What does that mean, 10x plus y? 10x plus y is nothing but the number xy. Because xy in the place value system, if you expand it, it will give you 10x plus y. X is in the 10th position, and y is in the yth position, means ones position. So 10x plus y is nothing but the number xy. So the moment you subtract 20, so you have the number xy. So you know the two unknowns being secretly chosen, x and y. So this is the proof why this magic works. It's not something supernatural, or it's not something that I'm doing a mere trick or an illusion. It's a magic which works. It's a magic for which there is a proof. And you need to understand the proof. Now, my next question to you. My next question to you is on the same magic. I just wanted to verify that you have understood it. So in step 3, Mangsu, can you please go back to the slide? Yeah. In step 3, I have added 4 with the number obtained in step 2. Instead of adding 4, if I add 5, how your magic has to be changed in order to make this trick work? Just think about it and let me know. What adjustment magician is required to do?
Right, students. So the question is at step 3, if instead of adding 4, if in this magic we were to add the number 3, what would be
Number
the
5?
Number 5. Number 5.
Yes, number
What
5.
would be the
What adjustment magician needs to do?
All right, students. So please type in your comments and your thoughts in the comment box. Let's see if anybody is able to understand and come up with their suggestions. And feel free, students. There's no issue if you're trying. Everyone should at least try and give in their suggestions in the comment box. How will it change this entire magic? All right, so there's Radhika, Tanisha, there people are trying. Govind is saying subtract 5 more. Murukeshan is saying multiply by 6. Garvita is saying subtract 25. Bhadra Vinith is saying so 5 into 5, so 10 into plus 25 plus y. All right, so Narsimha is saying subtract 25.
Yeah, subtract 25 is the adjustment that magician needs to do. Everything remains same.
Yes, so Roy, Manoj, a lot of people have given the right answers by now.
Yeah.
Okay, tree color is also
So
saying
this is
separately.
how you can craft your own magic. This is how you can craft your own magic. Now, on the same line, I'm going to give you an exercise. You can think about it at your leisure time. In step 2 and step 4, I'm doing, in step 2, I'm doubling the number, and in step 4, I'm multiplying by 5. What I will do, in step 2, I will multiply by 5, and in step 2, I will double the number. How your magic will change if every other step remains same, how your magic will change, or what magician requires to do, what adjustment he requires to do. Just give it a thought. This is number one. And number two is, in this case, I have taken two secret numbers. How can I extend this magic for three numbers, three secret numbers? So that means at the end, I will be getting XYZ. You can add some more steps. At your own will, you can add some more steps. You are free to add any more steps, but you have to ask from the subject three integers to be chosen secretly, XYZ. So these are the two things, two exercises that you can try out your leisure. Now I will get into the mainstream thing. So mental maths is really important. So I have already talked about this. So I will not spend much on any time on this, because you all know this very well: the speed, distance, time, how to budget your spend, how to save your pocket money, how can you manage your time for exam preparation, uh, how can you efficiently buy your plan in any mall or supermarket. So all these things comes under the application, real life application of mental maths. So let's now get into the multiplication tricks. I have some multiplication tricks for you. So let's get into those. So we have the basic multiplication tricks are basically from very childhood we are being talked about remembering the multiplication table, because that helps. That helps you answer your questions, or that helps you in solving problems where multiplication is involved quickly. That helps you solve your division problems where multiplication is involved, uh, or division is involved quickly. That helps you in various other contexts like factorization, because you need to do factorization and all. Prime factorization, you need to do prime factorization of a particular integer. So these are various areas where these tool or this multiplication table comes handy. Now, one thing to notice in these multiplication table, that from if you see this line, so 6 into 7 is 42, and 7 into 6 is also 42. So that means not the entire multiplication table you need to remember. If I draw a line into this diagram diagonally, only one side of the multiplication table, remembering one side of the multiplication table is sufficient. So that's what I wanted to mention here. 2 into 3 is 6. So 3 into 2 is 6. So 2 into 3 is 6. Remembering 2 into 3 is 6 is good enough. 11 into 9 into 8 is 72 is good enough. 8 into 9 is also 72. So it's remembering just only one side of these multiplication table. Now, getting to the next slide. So multiples of 5 always end with 5 or 0. You uh, know that very well. So there is nothing special about it. So any integer, if you remember, if you multiply with 5, you will end up getting a number which either ends with 0 or ends with 5. When it gets end with 0, when the number you are multiplying it with is an even number, then you will get 0 at the end. And if you are multiplying 5 with an odd number, then you are getting 5 at the end. In this case, 5 into 12 is equal to 60. 12 is an even number, so you are getting 0. Had it been 11, then you would have got 55, so which is basically an odd number. So you are getting 5 at the end. You know that. So the main reason why I have mentioned it over here, basically these are cross checks, what you need to do while solving problems, because many of the times we lose marks because of silly mistakes, and these silly mistakes happen can happen in any way you don't remember. You cannot even figure out. You have to be alert, and these alerting can only happen if you remember these type of sort things. So you have done your problem solving correctly. While writing the answers, you are writing 61. So something should trigger in your mind that I have multiplied 5 with 12. How come it could be 61? It should be either ended with 0 or 5. So I might have done something wrong in writing it. So I should go back and cross check whether I have written it down correctly or not. And these are the things that can help you trigger your thoughts. So that is the main purpose. It's not that you don't know it. It is very simple. But always have a checklist of this kind of thing in mind, because that will help you while you are trying to solve problems in an exam setting, because you are time pressed. So these will keep your thoughts or help you be alert. Next. So the same thing. Now I will continue with some more numbers. So these are basically when you multiply 6 with any single digit even number, the product has same unit digit. So 6 is multiplied with 4. So you are getting 24. So at the end you have 4, and you have actually multiplied 4 uh, with 6. 6 multiplied with 8. So at the end you see 48. If you see 6 multiplied with 14, what is the outcome? It's 84, right? The same holds. So is the case for 6 into 18. So these are simple things that you should keep in mind. So these will be your checklist. These will go into your checklist. Next slide. A multiplication by 7, multiplication by 9. So it's easy. Multiplication by 9 is easy. So you can do it very quickly by multiplying it by 10 and then subtracting the number from it. So 9 into 7 is equal to 63. So this is, you know it very well from the table. But if you just do 70, multiply it by 10 and then just subtract 7 from it, then you will get the same number. It's a simple example. But say, for example, 9 into 11117. So then you have to start doing it, right? So in that case, if you just multiply 117 with 10, so that is 1170. And from 1170, you subtract 117. That might take you less time, depending on how efficient you are doing subtraction. So you need to think about what applies good for you. You need to think about what is your best strategy. I'm not saying that it is the best strategy. I'm giving you some tricks. What is best for you? You have to think. You have to apply these tricks several times. And then only you will understand that which one is your best strategy. Like any player, they know their strengths and weaknesses. So some lawn tennis player, they have a very strong backhand drive, and someone is very good at serving an ace. Someone is very good, very strong in forehand. So accordingly, they design their play. So the same thing applies over here. You need to know all the sorts. You need to know all the tricks. But whichever applies Whichever suits best for you, you have to decide. Now, next slide. So this is 7 trick. So what we do here, we double the integer, which is to be multiplied by 7, and then add to it half of 10 times the integer to get the desired result. So what we have done, so in this example, you can see 10 times of 132, which is 1320, that has to be divided by 2, and we are doubling the integer 132, which is 264, and then adding the two components to get the result. It's nothing new. Basically, what you are doing, you are dividing 7 as 5 plus 2, right? Now you are doing 132 into 5 plus 132 into 2. So 132 into 2 is basically 264. That's doubling the integer that you are going to multiply. And instead of multiplying 132 with 5, what you are doing instead, you are multiplying it by 10 and then halving it. So 10 by 2 is 5. So you are multiplying by 10. So that becomes 1320 and then halving it. So you are getting 660. So this, if someone can multiply with 5 quickly, then probably he doesn't need to multiply with 10 and then halve it. So it depends on what works best for you. But these are the ways you can think about, because you need to calculate it mentally. You need to do it quickly. So instead of doing it on a pen and paper, you can quickly double it, because that's easy. And then you can multiply with 10 just by adding a 0 at the end. And then you can quickly halve it and then add it. So these things can be done mentally. But instead, if you go on multiplying 132 into 7, you have to remember so many carries in order to come up with the result. That may suit you if you are good enough in doing that. But you should know all these tricks. Now the next slide. So this is 11 trick. How we can do or how you can quickly multiply any 2-digit number with 11. So there are 2 examples being given over here. One is 14 into 11. So since you are multiplying 14 with 11, and the first digit of 14 is 1, so you have 1 at the tens, hundreds place. And then since you are multiplying 14, you have to add these 2 digits, so which is 1 plus 4. So 1 plus 4, that is 5, which is coming in the middle. And at the end, you have 4, because 4 is at the ones place of 14. So you get 154. So this is the logic that you have while you are multiplying with 11, any 2-digit number. But that doesn't hold good. It holds true whenever the sum of the 2 digits is less than equal to 9. Until then it holds. Say for example, if it is 15, the same trick would have hold, because 1 plus 5 is equal to 6. It would have been 1, then 1 plus 5 is 6, and then you have 15. So here it is 5. So 1, 6, 5. So 15 into 11 is equal to 165. If it is 16 into 11, then you would have done the same thing. 1, then 1 plus 6 is 7, and then you have 16, so 6. So 176. So this is how you could have computed. But it doesn't hold true when the sum of the 2 digits is greater than equal to 10. Here in the case, in the next example, say here we have to multiply 86 with 11. So 8 plus 6 is equal to 14. So it's greater than equal to 10. So earlier rule will not hold true. So what you have to do now, So 8, you will have to increment. So 8 plus 1, you have to do. And 6 is at the ones place. So blindly you can put 6 in the ones place. And 8 plus 6 is equal to 14. So that 4 will come in between. So it will be 9, 4, 6. So it will be 9, 4, 6. So you can see here 8 plus 1. And then 8 plus 6 is equal to 14. So that 4 is coming in the middle. And then 6. So it's 9, 4, 6. So if I now ask you to multiply 75 with 11, what will be the result? Can you please let me know? 75 multiplied with 11. Can you just give it a try?
Right, students. So please do type in your responses. Try with this method exactly how it is shown. 75 into 6, right?
75 into 11.
75 into 11. All right. 75 into 11. All right, students. Please type in your comment box. Okay. So there is Nagorao, Shruti, Kritika. Yes, guys, you have to type in how you have arrived at this and type in the final number that you think the answer is. All right. So right, some of the students have started to type 825, like Prathish, Payal, Ganesh, uh, Noob, Satyam. Everyone's typing 825. Also, students,
Yeah,
do
that's
type
the
in
correct
how
answer.
you arrived at this. Yeah. Right. So a lot of students, Yashvi, Malshi, Neelam, Ayush, Deepika, Akshara, everyone's typing 825.
Yeah, that's fine. It's the correct result. So I hope that they have understood the trick. So now let's move on to the next trick. So the next trick is 7, 11, 13 trick. So it's nothing special about the name. It's basically multiplying any 3-digit number with 7 and then followed by 11 and then followed by 13. So the rule says like this: multiply any 3-digit number XYZ with the numbers 7, 11, and 13 respectively. The result will be XYZ, XYZ. So you don't need to do anything. You just repeat the two numbers one after another. So you have started multiplying 432 with 7 and then 11 and then 32. So without doing any computation, you can write it simply as 432, 432. So that's simply your answer. Why? Why this works? Now, why this works lies in the fact that what is the result of multiplying 7, 11, and 13. So I ask you to figure out what is that you are getting if you simply multiply 7, 11, and 13. Just leave aside 432. Just simply multiply 7, 11, and 13. And what is that you are getting? Tell me.
Right, students. So what will you get when you multiply 7, 11, and 13? So it's in front of you. Only have to multiply 7 into 11 into 13. So what do you get as the result? Right. Very interesting. So yeah, I mean, students are typing in 1001. Rajni, Shelly. All right. Right, Deb. So students are typing in 1001 as the result.
So this is the reason. So if you now multiply any 3-digit number with 1001, you will get the same pattern: XYZ, XYZ. You can do the multiplication and can verify. Say for example, if you are multiplying by Z, so your first row becomes Z00Z. Then you are moving one side on the left side, and your next number is Y00Y. And then again, you are moving one side left, and your next number after multiplying is x00x. Now, when you are summing all these three rows, what you are getting is xyz, xyz. So this is why it works. So these are the kind of tricks that you should keep in mind, and you will you will find all these things, you will feel amazed. Now I'll go to the next trick. So it's a 15 trick. It's pretty simple. It's nothing special about. So you first multiply it with 10 and then add half of it. So 15 into 18. So you have multiplied 18 with 10. So you got 180. And then you are just having 180. So that's 90. And then you add these two numbers. So 180 plus 90 is equal to 270. So that's your answer. The same thing holds for 15 to 33. You multiply with 10. So 33 into 10 is 330. And then you have 330, which is 165. So 330 has to be added with 165. So you get 495. So this is how you can do multiplication with 15 quickly. Next slide. So I have a few questions for you. So you can try that one. Any one or two questions, you can try that one. Particularly, I would love to see that whatever you are getting, if you multiply 3367 with 30.
Right, students. So please do type in the responses and try out the G exercise first. Do type in your responses to the exercise G right now in front of your screen, 3367 into 30. Type in your responses on the comment box. Yeah, so students have started to write the responses. All right. So, yeah, so a lot of students are typing in responses to the other exercises. So, students, whichever once you're answering, do type in A, B, C, D, whatever is the exercise number against it, so that we understand which answer. So, for instance, a student is typed 1, answer 36. Yeah, you can do like this, or A equal to 36, whatever. Right. Here we are talking about the G exercise 367 into 30. You have to do it mentally. How you can do this calculation mentally, please type in your response in the comment box. All right, so yeah, students are typing in 101010. So Barsha, Sarkar, Anil Gupta, Adarsh, Murukesh, Gautami, everyone's typing 101010.
Okay, right.
Veronica.
That's correct. The main reason why I have asked this is basically just write 30 thrice and divide it by 3. What you will get? So 3367 has to be multiplied with 30 and your answer is 101010. That's correct. What I'm saying, since you are multiplying 30 with 3367, so what you can do, you can write these 30 thrice consecutively. So it will be 303030, and you can simply divide it by 3. That will be your answer, which you have already got 1010 and 10. Now since it is 30, so it is easy for you to multiply it quickly. Now just do this exercise for 31. It will take time for you, but it will not take time for anyone else who is using this trick. So you, what you do, you write 313131 and divide it by 3. You will have the result of 3367 into 31. Isn't it interesting?
Yeah. So again, a lot of students are saying it's extremely interesting. Manjula, they're I think amazed by this calculation.
Just write it down: 31, 31, 31, 31, and divide it by 3. What you will get?
Yeah, students, please type in your responses here. 31, 31, 31. Right, you have to write it 3 times and divide by 3. Right. So 3367 multiplied by 31, students. Okay, the answer you're okay. Some of the students are saying answer is 104377. Okay.
Yes, answer is 104377. You can do that by doing the normal multiplication, 3367 into 31. But instead, it's much easier if you just divide it by 3, right? So keep it in mind, all these tricks. I think that will help you. So this is all that I have for now. If you have any questions, you can ask me.
Great. This is really helpful. We've been receiving a lot of, especially comments and appreciation words from students throughout the session. But students, this is a time for you to ask all your doubts, anything related mental mathematics that you want, or anything related to mathematics that you want to ask, or anything which was not clear to you as part of this session. Please feel free to ask. Mr. Debapriya will be very happy to answer your queries. We are really short on time, so maybe 2 or 3 questions can be taken up. So I would request, like, if you can just type in any sort of question that you have. Uh, so, all right, we've started to get a lot of questions. So, like Kshitij from Indriani English School is asking uh, interesting ways, how to do mental calculation so fast. So he's I think wanting to understand how to improve the mental calculation bit.
Basically, in order to improve mental calculations, you need to equip yourself with different tricks. You need to practice all these tricks multiple times. For example, these 11 trick, these 3367 trick, these 31113 trick, 71113 trick. So all these things you should practice uh, more number of times, so that that gets assimilated into your blood, so that when the situation arises, you can quickly relate to the exact situation which you can apply, and that automatically will save your thinking time. And then rest is basically doing the mere calculation. Most of the time that we spend while trying to solve one problem is basically while we are thinking what is to be done and what is and how it is to be done. And then the normal way of doing things also takes time. But if you can save your time, and that saving of time can only happen if you have enough tricks known, and if you know, if you can quickly point out that which tricks can be applied for which problem, then you are well ahead of others in the competition. You can hardly make any difference in the competition, because the computation will anyway take time for each and every one. Now tricks, applying tricks will save some time, but anyway you have to do that. Say for example, in this last example, someone will try to do multiplication 3367 into 31, and I will do what? I will write 313131, and I'll try to do divided by 3. So here I will save some time in doing this computation. But if I don't know this, then I will follow the same strategy, multiplying 3367 with 31, and then hardly I can make any difference. So you not only need to know the tricks, you should also be equipped with the tricks by knowing that by practicing it more. Uh, applying it more and trying to solve different type of problems. There are plenty of different sites available where you will get enough of these questions online, so you can try those things out and can see that whether you are being able to solve them properly or not, and that will slowly help you increase your mental math skills.
Sure.
It's all
Thanks.
about practicing.
Thanks, Dev. Maheshwaran is telling us, thank you so much, because now I have easily understood the multiplication tricks. This is very easy. You've made it sound very easy. Gautami is asking, sir, how many times we need to practice mental maths? Like how many hours every day should we spend on this?
I will suggest that given the grades that you have, so basically you have enough of material to be consumed, enough of mathematics concepts to be cleared, enough of mathematic problems to be solved, and apart from that, there are many other subjects that you have to study too. So don't think that you have to set aside a particular time for doing mental maths. Rather, I will suggest that every day you should keep at least 2 hours set aside for doing mathematics. And whenever you are trying to solve certain mathematics problems, you will anyway encounter different multiplication, division, addition, and in many other HCF, LCM kind of problems. And whenever you there is an opportunity to do it quickly, or whether you see you try to measure that last time when I solved these 5 problems, I took around 5 minutes on an average. So it took around 25 minutes to solve 5 problems. Next time when I will do these 5 problems, it should take me 20 minutes. Next time when I will do that, I will squeeze that to 3 minutes per problem. So it should be solvable within 15 minutes. So these type of milestones you should keep for yourself. So when you will have these type of milestones set for yourself and you will try to achieve those milestones, so you will automatically will search through different tricks. You will automatically will try to apply different tricks while trying to solve one factorization problem, or while trying to solve one division problem or any multiplication problem, and automatically your mental math skills will automatically be increased. It's not that you have to set aside separate time for it, but you can have separate time for reading skills, reading mental math skills, because if you don't know skills, then you will not be able to apply those skills. So you can set aside some time, say for example 2 hours a week or 3 hours a week for studying mental math skills from some mental math kind of mental math books. So then whatever you have learned in a week, you will try to apply that in the forthcoming weeks. So that is how you can improve your mental math skills, and not only just mental math skills, that will anyway help you to enhance your math skills too.
Right. Thank you, Deb. We're really running out of time. Let's just take one more question. So this is from Murukeshan Srijit. So he's saying, I usually make simple mistakes because I get nervous during my exams. Do you have any tips which can help me not get nervous during exams?
I have only one tips for you. You should not be nervous. You should practice more, because your nervousness comes because you don't feel confident, and you don't feel confident because you don't practice more. Now number of times you should practice, it depends on person to person. Someone needs to practice thrice, someone needs to practice 5 times. So if you, the number of times you are solving a particular problem, if it is not sufficient, you you try to double it, or you try to solve it 2 or 3 times more. Over a period of time, you will see that it will vanish. Your nervousness will vanish.
Great. This is really helpful. We would have loved to continue talking to you, Mr. Depriya, for hours, given the kind of questions we are continuously receiving from students, but we've really run out of time. So thank you so much, Mr. Depriya, for sharing your journey and tips on mental maths. This will
Yeah, thank
definitely go a long way to help acquire one of the most important skills for thousands of students listening to you today. Students, one
you. Yeah,
request: please do take out 1 minute to fill in the feedback form. The link for the same is pinned right at the top in the comment box. It's also there in the description of the video. It really helps us to improve and bring in your suggestions in the next few sessions that we take. So won't even take like 10 seconds. Just click on the link and fill in the feedback form. You can keep it open even after this session, you can fill it, right? And just a reminder, we have the next session lined up on January 23rd, 1 p.m. for your batch. So we hope to see all of you on January 23rd. And thank you once again on behalf of all the students, Mr. Debapriyay.
Thank
Have
you.
a great day, everyone. See you very soon. Take care.
Yeah, yeah. Bye.